All right, we have a 2002, I believe it is, Jeep Grand Cherokee with the 4-liter. Complaint of an intermittent stall and then crank no start, which eventually led to a full-time crank no start. Came to me from another shop, wanted me to take a look at it. They were pretty focused on the skim module being an issue because the skim light would be on in the dash, or the security light would be on in the dash whenever this would stall and whenever the crank no start situation would be present. So I already figured this out, but we're gonna go back through this and go over it because it's a good thing to remember. It's relatively basic, but it can send people in loops. Like right here we got, appears to be a newer or a reman PCM at some point. They were in there probing around, seeing what was going on there. So we have on the dash here, right there, and then this guy right there, ooh, focus, is that skim light or the security light they were talking about. So we've got us a crank, 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 crank. Sit here cranking all day long, won't do a thing. So I figured we'd start with regular scan. This is going to be a Jeep. It is a 2002. We're going to try automatic ID. And we're going to fast forward. Boom, 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 boom. All right, so we're going to manually ID this. Grand Cherokee 4-wheel drive. Big 4-liter powerhouse. We're going to click OK. And we're going to go after the skim. Codes. No communication. All right, let's go after engine. Boop, 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 boop. Do, 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 do. There we are, codes. Waiting for module, and no communications, which is the fault we had. So, we'll go over some basics here, and we're going to hop over to the computer screen to do that, and then we will hop back here and go over our next round of testing for this, which will be powers and grounds, yada, yada, yada. We'll see what we got. All right, so let's just quickly run through this skim or skis indicator light. So right here we got it highlighted. Each time the cluster receives a skis lamp on message from the skim, lamp will be illuminated. Lamp can be flashed on and off or illuminated solid as dictated by the messages from the skim. We can go into more detail, but lamp remains illuminated until the cluster receives a lamp off message from the skim or until the ignition switch is turned to the off position. Now we also down here have a VTSS indicator light, a vehicle theft light, which is different from the skis light. That theft light is actually a little red flashy LED up on the dashboard. In this case, yes, we do have a skis message or a skis light. We do not, however, have an anti-theft light flashing. So that kind of directs us away from dealing with that skis setup right now. So let's pull up a schematic and focus on powers, grounds, comm lines, all that for this PCM. Chrysler's backwards with pretty much everything. We only got a couple powers and a couple grounds. So we've got an ignition switch output, which is a 12 volt. Then we've got our 5 volt reference, which we're going to be checking out as well. Our fused battery voltage, 2 grounds here, and then all the way on the other side here is on connector 3, which will be the far left. We've got our SCI transmit, SCI receive, PCI bus. Now, like I said, I already figured this out. And one of the first things I did was check powers and grounds to the PCM, knowing we didn't have comms. I then threw my breakout box in there, and my SCI lines were completely dead. Nothing going on there. PCI bus was a normal pulsed waveform. Videos out there on that. That's a video for another time. We're just kind of running through. That really didn't leave me with a lot of other options other than what else can make a PCM go to sleep or not function. We didn't have any of the indications of a shorted bus or a broken wire or anything like that. So the next place to check is the 5-volt reference. And I'm going to pull up a diagram here in a second to show you why. Alright, right here we have just a generic, well not generic, this is specific to the 18 Mega 328. This is a microcontroller, not the microcontroller that's in this PCM, but same concept. And at the end of the day, really all we need to know here is microcontrollers need a certain turn-on voltage. They need powers, they need grounds, just like anything else we deal with in the automotive world. In this case, it's going to be pin 7. This VCC is going to be a 5-volt, just like inside this Chrysler PCM. And what happens is, generally on this older stuff, I can't speak so much for the newer stuff with any definitiveness, but with the older stuff, you're going to have your 12 volts coming in on your power supplies, you're going to have your grounds coming in, and you're actually going to have reference circuits or voltage drop downs within that computer to regulate that 12 volts down to a 5 volt. So if any one sensor is shorting the 5 volt, not only will it take down the regulator, but as a side result, it will also put this microcontroller to sleep, which means the rest of the ECU can't do what it needs to do. It cannot execute its prime directive. It just won't work. So what we're going to do, like I said, I already know what's wrong with this. We're going backwards on it. I'm going to tell you right now, powers and grounds were great under loaded testing. Comm lines, like I said before, were wonky. And so now we're going after our 5-volt ref. So we're going to run through that and check it out, see what we got. Yeah, right. We didn't quite so much hop as gracefully strode back over here. But what we've got going on is we are currently back probed into the 5-volt reference, in this case on the map sensor, easy access point. And you will see here, or here, or here, or there, or somewhere, the multimeter, and we've got 0.33 volts on it right now. And like we discussed in the other part, we already know powers and grounds are good. We got wonky communications, or lack of communications to the module. So we're gonna go after the 5-volt reference circuit here, especially because this doesn't have a lot of them. It's got 2 branches, as we discussed, but 4 or 5 sensors. So we got our map sensor, TPS, cam sensor down here, crank sensor, and engine oil pressure sensor right about there. So we got that 0.33, which is no good. We're gonna unplug and still at that 0.33. Next, we're gonna just simply go after this throttle position sensor. We will return after a short commercial break. And now that the word from our sponsors has ended, we got that little guy off there. And you'll see we're still sitting at 0.33 volts on the 5 volt. So that is not our issue. So we're gonna come over here to Mr. Cam sensor here. And we may need another word from our sponsors here in a second. Yeah, we'll be right back. Yeah, it's a lot harder to do this one-handed than I remember. But you'll see, we're still sitting at our 0.33 volts. So that is not the problem. There. I don't know if you guys are gonna be able to see it, but right down in here, we have our engine oil pressure sensor. And we're gonna unplug that. And 0.33 volts. So that leaves us with the crank sensor, which should be right about here. All right, so that leaves us with our crank sensor here, if it'll come apart for me. And I don't know if the camera caught that, but we just got some noise and all that. And we're back at our 5 volts. So we got our 5 volts back. Let's go here. Try communicating. Codes. No codes present. All right. Data display. Collecting data. Come on, come on, come on. God. Jeep all over my hands. And we've got all that live data. And just to prove a point, let's take this and that. Shaky cam. All right. And just to prove our point, I'm gonna plug that sensor back in and we lose comms. So what we have is a shorted crank sensor. Now, like I said, there you go. It just did its beep, beep, beep again. Like I said, I had already figured this out, but this little guy here, right, shorted together inside. All the wires started crossing, hanging out, doing things they weren't supposed to do, and that took that little 5 volt reference that the computer needs to run its stuff, shorted it, brought down the whole turn on voltage for the MCU and the ECM and all that, and just basically put everything to sleep. Said, I ain't got time for this, I'm not working, we're done with it. So now, give me a minute, I'm gonna go back down in La La Land here, get hooked up to the new crank sensor that's already in that little devil of a hole down there that is a pain to get to, and we will prove the fix. Right, so now we're back inside, boom, 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 and comms are restored, we've got data stream, we've got RPM, and it runs. Got a little bit of a hiccup or a miss to it. Doesn't appear to be from an erratic RPM signal, but that is for that shop to figure out, not for me. And that's it. Closing remarks, maybe. If there are, they're right after this. If not, have a good one. So, what we had was a relatively simple failure. Crank sensors are not by any means uncommon in that year and that configuration on a Chrysler by any means. So, relatively simple failure that shorted the 5 volt. Not the most common failure mode I've seen for those crank sensors, but I'm sure others have seen them quite a bit more than me. So once it shorted that 5 volt, it brought down the 5 volts needed to turn on the microcontroller in the ECU, and that put everything to sleep, which also effectively was illuminating that skis light, which sent the other shop off in kind of a weird direction, and they were chasing themselves a little bit. But we backed up, went back to basics, checked all the regulars, and we found a pretty simple failure, fairly easy fix. So it is a bit of a pain replacing those crank sensors. And that's that. I mean, sometimes step back, get a second opinion, or just go through and kind of rethink the basics. When I was working on equipment full time, I ran into a lot of 5 volt ref issues, so it still stays in my general toolbox. But if it's something you don't see a lot, you don't always think about it. So it's a good thing to keep in mind. Relatively easy test to perform. A lot of scan data will show short at 5 volt references. GM comes to mind, but it all depends on whether or not you can communicate, depending on the system architecture and everything else. So keep that in mind too. Everything has its own uses, times it can be used, times it can't. So it is what it is. That's all. Take it easy.